we are going to work another example here a little bit more slowly. So starting here with number 6, I'm given a transformed function and I want to first identify the parent function. Remember, the parent function is some constant raised to the x power. So if I look at my transformed function I'm given here, the constant that I can pull out raised to a power is going to be 3 to the x. So that was my parent function. So let's look at what's different here and identify our transformations. So I have this -2 in my exponent, and that indicates a horizontal shift, and because it's negative, that means it's to the right 2. And then I also have this -7 on the outside, so that's a vertical shift, and because it's negative, that means we're going down. So to the right 2 and down 7. And we can do this similarly to how we did the previous one by finding points for the parent function and then just move them right 2 and down 7. So let's first find a couple points for our parent function by making our little t-chart here with our values. So this is for our parent function. And now if I plug in -2 for x, I'm going to get 0.1 repeating. If I plug in -1, I'm going to get about 0.3 repeating. If I plug in 0, I get 1. Plug in 1, I get 3. Plug in 2, I get 9. So that was our parent function. And now I need to find the points for my transformed function by moving all of my x values right 2 and all of my y values down 7. So to the right, I'm going positively. So I'm going to add 2 to each of my x values. So I'm going to end up with -2 plus 2 is 0, -1 plus 2 is +1, 2, 3, 4. These are my new x values, my transformed x values. Now I'm going down 7, so I'm going to be subtracting 7 from each of my y values here. So 0.1 minus 7 is going to be -6.8-ish repeating, and then -6.6 repeating, -6, -4, and 2. And these are now the points, that I'm going to start graphing. So 0 down to 1, 2, 3, about 7. 1 is a little bit higher. 2 is actually at 6. 3 is at 4. And 4 is at 2. Okay, so this is my transformed graph. And here we can draw in our asymptote where our graph is getting really, really close to, oops, I meant to do that blue. Where our graph is getting really, really close to, but not quite touching. So let's talk about domain and range, our x and y values. Our domain, again, x can still exist everywhere, so domain is still all real values, or -infinity to +infinity. Our range, though, do you see how there's a cutoff here at -7? So y can be anything above this line, but not below it. So y is greater than -7. And our end behavior, again, we're just going to the right or to the left of our graph. So as we look to the right, y is increasing. So y is going to infinity. And as we go to the left, y is decreasing and getting really, really close to -7. And remember, y-intercept, that is when x is equal to 0. And if I, in my calculator, plug in 0 for the function 3, 0 minus 2 minus 7, I get 3 to the -2 power minus 7. And we know 3 to the -2 power is that 0.1 repeating minus 7 gives me about 6.8 repeating. So my y-intercept is at 0, -6.8 repeating. And again, asymptote, we already drew that in. That is at y equals -7.